So good day everyone. So now let's talk about the graphical representation data. So first is histogram. A histogram is a kind of bar graphs. It displays frequency and class intervals using vertical bars. So a histogram is a graph that shows data distribution using bars. So, before to move forward, unsa di kalahian sa bar graph o sa histogram? So first, ang histogram is wala siya mga gap between sa mga bars. Because ang histogram is used to display continuous data with a continuous measure like kanang mga heights, width, or temperatures. Ang histogram is used for quantitative while ang bar graphs is for categorical data. So, ang histogram is kanang nagashow siya og shape of distribution while ang bar graphs is comparing variables only. So, I give you some example. Let's see here the frequency distribution table of 30 students in their language test in English. So, here's the table. So, let's construct a histogram. So, let's draw a y-axis and the x-axis. The y-axis is for frequency and the x-axis is the class boundaries. So, makita man nato din sa frequency no, din sa table na dugol kayo ang ilang mga numbers like tag-isa lang ka gap. So, then the atong sugdan din sa frequency is the 1, 2, 8. The last number is the 7. So, dagdagan na to siya isa ka number. So, and then the intersection sa y-axis and this x-axis is 0. Dinhi sa ubos. Yeah. So, dinhi sa sa x-axis, ibutan po na to ang class boundaries. Which is, sugod sa nagdanan, sugod sa lower to highest. So, dinhi sugdanan nato ang pagdraw sa mga bars sa histogram. So, first is 17.5 to 26.5 which is ang iyang frequency is 6. So, isukod nato siya sa y-axis nga number 6 ang 17.5 o 26.5. So, next is the 26.5 to 35.5. So, iyang frequency is 5. So, i-drawing po nato na ang bar dira. So, sa ikatulo is 35.5 to 44.5. So, iyang frequency is 4. So, ikuha na to na siya, i-drawing ang bar. So, ang ikaupat is the 44.5 to 53.5. So, iyang frequency is 5. So, next is 53.5 to 62.5. Ang iyang frequency is 7. So, i-drawing that. So, ang next and the last is 62.5 to 17.5 which is ang iyang frequency is 3. So, na-forma na nato diha ang histogram. So, kining histogram is naga-help sa atoa to understand how the data is kanang spread out. Ug manotice nato where the data is concentrated or sparse. So, the second one is the box plot or the box and whisker plot. So, a box plot is a graph summarizing a set of data. So, ang shape of the box plot nag-show how the data is distributed and it also shows any outliers. So, ang box plot useful kini the way to compare different set of data. Then the box plot also this can be pa-horizontal or pa-vertical. So I give you example of box plot without outliers. So Here's the data of a series of hourly temperatures were measured throughout the day in degrees Fahrenheit. So a box plot of the data set can be generated by first calculating the 5 relevant values of this data set. So first is the minimum, the second one is the maximum, the third one is the median or the second quartile, the fourth one is the first quartile, and the last one is the third quartile. So the minimum is the smallest number of the data set. So which is dinis atong data set is ang pinakagamay na number is 57. And then the maximum is the largest number of the data set. So makita man nato diri na ang pinakadako nga number is 81. And then the median is the middle number of ordered data set. So which is na siya sa middle na number sa data set. The first quartile value is the number that marks 1/4 of the ordered data set. So the first quartile value can be easily determined by finding the middle number between sa minimum and the median. So ang sa makita nato dire ang middle sa 57 and 70 is 66, which is mo na siya ang first quartile. Then the third quartile is the number that marks 3/4 of the ordered data set. So the third quartile value can be easily obtained by finding the middle number between sa median and the maximum. So makita man nato dira sa middle number between sa 70 and the 81 is 75 rather. 75. So mao na siya ang atong third quartile. The interquartile range or the IQR can be calculated by subtracting the first quartile value from the third quartile value. So IQR equals to quartile third minus first quartile is equals to, so ang atong third quartile is 75 degree Fahrenheit minus sa atong first quartile which is 66 degree Fahrenheit. So ato nang i-subtract sila. So ang equal is 9 degree Fahrenheit. So 1.5 IQR is equals to 1.5, which is ang atong IQR is 9 degree Fahrenheit. So ato na silang i-multiply, which is ang equal nilang duha is 13.5 degree Fahrenheit. So 1.5 IQR above the third quartile is, so third quartile plus 1.5 IQR. Muna ito ang formula. So ito na siya ang sundon. So atong third quartile is 75 degree Fahrenheit plus ang atong 1.5 times 9 degree Fahrenheit, which is ang 13.5 degree Fahrenheit mo na siya. So ato nang i-add silang duha, which is ang total nilang duha is 88.5 degree Fahrenheit. 1.5 IQR below the first quartile is, so ang formula na to is first quartile minus 1.5 IQR. So mana siya. So ito na sundan. So atong first quartile is 66 degree Fahrenheit minus 13.5 degree Fahrenheit. So ang total ng duha is 52.5 degree Fahrenheit. So here 1.5 IQR above the third quartile is 88.5 degree Fahrenheit, and ato ang maximum is 81 degree Fahrenheit. So therefore, atong upper whisker is i-draw na to siya at the value of the maximum, which is 81 degree Fahrenheit. So diri pod sa 1.5 IQR below the first quartile is 52.5 degree Fahrenheit. Then ang atong minimum is 57 degree Fahrenheit. So therefore, ang atong lower whisker is kanang i-draw na to siya at the value of sa atong minimum, which is ang 57 degree Fahrenheit. So natin another example sa box plot with outliers. So in this example, only the first and the last number are changed. So the median, the third quartile, the first quartile remain the same. So kini siya atong maximum value in this data set is 89 degree Fahrenheit, and 1.5 interquartile above the third quartile is 88.5 degree Fahrenheit. Then ang atong maximum is greater than 1.5 IQR plus the third quartile. So atong maximum is an outlier. So therefore, the upper whisker is ato na siyang isulat or ibutang at the greatest value smaller than IQR above the third quartile, which is smaller sa smaller sa 1.5 in quartile, which is ang 88.5. So which is ang atong ibutang diri is 79 degree Fahrenheit. So ang minimum value in this data set is 52 degree Fahrenheit, and ang atong 1.5 IQR below the first quartile is 52, diba? 52.5 degree Fahrenheit. So ang minimum is smaller than 1.5 IQR minus the first quartile. So ang atong minimum is also an outlier. So therefore, ang atong lower whisker is ibutang nato siya at the smallest value greater than 1.5 IQR below the first quartile, which is sabi natong below 57 degree Fahrenheit.
This is JNG Quaton, and now I'm going to discuss about the frequency polygon and the ogive. So a frequency polygon, it is a kind of line graph that represents the data. It is a graph formed by using line segment to connect the class mark or the midpoint and each class internal plot against their corresponding frequencies. Usually drawn from histogram, but can be drawn even without histogram. So it is used to depict the shape of the data as well as its trend. It allows easy comparison of multiple datasets by overlying polygons. So the y-axis, which is the vertical, is the frequency, and the x-axis, which is the horizontal, is the midpoint or the class mark. Now, let's proceed to an ogive. An ogive is a type of frequency polygon that shows cumulative frequencies. It shows a growing or lessening total. It is used to determine how many numbers lie before or above in particular values on data. So the y-axis is the cumulative frequency, and the x-axis is the class boundaries or the class limits. So there are the two types of ogive, which is the less than ogive and the more than ogive. For the less than ogive, the x-axis displays the upper class limit of each interval. This represents the maximum values for each class boundary. Points are plotted against these upper limits to show cumulative frequency. For more than ogive, the x-axis displays the lower class limits for each interval. This represents the minimum values for each class boundaries. Points are plotted against these lower limits to show cumulative frequency.